Hi, this is my introduction to 11.1, which is on sequences. So this is the start of a long chapter, right? Okay, on sequences and series. Okay, and so let's get started. So let's try to understand what a sequence is. So if you look at a sequence is a bunch of numbers, like the first one you see, 1, 4, 9, 16, 15. The only thing is that it has to go to infinity. There should be infinitely many numbers. But at the same time, we should be able to label the numbers as the first number, second number, third number, fourth number, right? And fifth number and sixth number and so on. So anything that we has can be labeled, okay, as the first, second, third, and all the way to infinity, okay, is really a sequence. Now so this is a sequence. So another thing is that the in a sequence the numbers don't have to be different. So this one, if you look at 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, it is a great sequence, right? So if you take this one, 3, 1, 4, 1, 5, 9, if you wonder what this is actually, these are the digits of pi. You know that digits of pi go on forever, right? Okay, 3.14. So 314. So that's also sequence because you can say that this is the unit digit, right? Okay, and then this is the 1/10th digit and so on, right? Okay. The first decimal, the second decimal, third decimal, and all that. So this can be the first digit and second digit and so on, right? Okay, of pi. So this also function. If you look at this, 1/2, 1/4, 1/8, 1/16, right? That's also a function, right? Okay, and it goes on, right? Okay, as long as it doesn't stop. All right, and then here is another sequence, right? So these are all sequences, right? Okay. And now one of the first things that we look for in a sequence is whether the sequence is convergent. Okay, is the sequence convergent? What do you mean by that? That means that the sequence has to approach a single limit, has to approach a single limit as n goes to infinity. So let's take say the sequence number 4, right? Okay, 1/2, 1/4, 1/8, 1/16. Now, if you kind of plot this, right, against n, and we have this notation for a sequence, so we call it a sub n, like that, right? Okay, n belongs to n. N means natural number, so that means this is like, for example, I can write this as a sub 1 is 1/2, the first one, a sub 2 is 1/4, okay, and the third one, a sub 3 is 1/8. It's like the label, okay, the first label, first is 1/2, second is 1/4, third is 1/8, okay. Okay, and then if you plot this, see what we will get. Okay, so this is your an, and we should get, what do we get? Well, first one for 1 is 1/2, so if we take this as 1, so 1/2. 2 is 1/4, 3 is 1/8, 4 is 1/16. You can see that it's actually as increases. This is heading towards 0. Okay. Will it touch 0 at any point? No, will it touch 0? It will not touch 0. But still, the limit of this as it heads to infinity, as n heads to infinity, right? An, you can say an goes to 0, or limit, we say limit an equals 0. In other words, we say that the sequence an is convergent to 0. Okay. On the other hand, if you take a sequence like 3 digits of pi, so you have 3, 1, 4, 1, 5, 9, and so on. So digits of pi have no pattern. So it does not converge. So it diverges, right? It's not reaching a single number, okay? Because there's no pattern. For another example, if you take the first one, right? You have 1, 4, 9, 6. There's a pattern here. We can say that the first one is, we are squaring, right? So this is 1, like 2 squared and 3 squared and 4 squared and so on, right? So it keeps increasing, you can see. So in other words, we can actually say the nth term is n squared. So that's another thing. Okay, and so then again we can say that an diverges. Why? Because it's just keep increasing. If you put the thing, it will just keep, one goes to 1, 2 goes to 4, 3 goes to, it's like a parabola going upwards. So just keep increasing. Okay, so it diverges. So I hope you got the idea of what convergence and divergence is generally, right, of a sequence, right? So now let's see what we can do, right? All right. So let's take what is known as a geometric sequence. So that's a good start place to start now. So if you look at this sequence that we saw earlier, right? One half, 1/4, 1/8, and 1/16, right? You can see that if you look at the ratio of any consecutive two numbers, so if you take 1/2 and divide by 1, so second divided by the first, I get 1/2. And again, if you take the third divided by the second, that is 1/4 divided by 1/2, I still get 1/2. And if you get this, the ratio of 1/8 divided by, that means the fourth divided by the third, right? Again, you get 1/2. And if you take the fourth divided by the fifth, actually, divided by 1, 2, 3, 4, fifth divided by the fourth, again you get 1/2. So you get the same ratio. Okay. So then what happens is this type of a sequence is called a geometric sequence. Right? Now if you think of the sequence as an, do we know what the nth term is? Well, the first term is 1, 1/2, right? 1, sorry, actually the first term is 1, okay? And the second term is 1/2, which can be thought about 1 times 1/2, right? Third term is 1/4, which is 1/4, which can be thought about as 1 times 1/2 squared. You can see that when you get the different terms, the common ratio, right, which is called the common ratio, this 1/2 gets into power. So if you take the fourth term, which is 1/16th, okay, that can be written as 1 times 1/2 to the, sorry, 1/8. Fourth term is 1/8, 1/2 to the 3. So you can see a pattern. When you have the fourth term here, you get the third power of 1/2. When you have the third term here, you have the second power of 1/2. You have the second term here, you have the first power of 1 half. So we can say that the nth term is what? 1 times 1 half to the power n minus 1. This can be written as 1 over 2 to the n minus 1. Now, you can say that what happens when n goes to infinity? Well, you have 1 over 2 to the n minus 1. The bottom keeps increasing, right? The bottom goes to infinity, leaving 1 at the top. Okay, so what happens then? You get a 1 over infinity type situation, which actually goes to 0. So in this case, right, the sequence converges to 0. But does that always happen? Well, not really. Okay, so let's take another example. Let's take example, say 2, 4, 8, 16, 32, 64. Now let's take the ratios. 4 over 2 is 2. 8 over 4 again is 2. 16 over 8, which is again 2. 32 over 16, which is again 2. 64 over 32, which is again 2. So there is a ratio which is common, right? So the common ratio, sometimes we call it R. R is equal to 2. So in the previous problem, right, we had this is the common ratio. R is equal to 1 half. Now you can very clearly see, right, without any hesitation, that the sequence keeps increasing 2, 4, 8, 6, 32, 64, and then so on and goes to infinity, right? And in other words, you can actually say that an is actually equal to, so what is it? So this is like, in this case, right, the first term is, let me call the first term 1, okay? Then the common ratio is still 2, right? Okay. It'll be 1 times, right, 2 to the second term is 2 to the 1, third term is 2 to the 2, fourth term is 2 to the 3, and fifth term is 2 to the 4, and so on. So the nth term is 2 to the n minus 1. Now you can see a difference. Here the n minus 1 was at the bottom. That's why it went to 0. Here in this example, n minus 1 is at the top. Okay. So because it's at the top, this goes to infinity. So that means the sequence is divergent. So you can kind of see a pattern here, right? When the common ratio, right, is actually less than 1. Well, strictly speaking, between -1 and 1, still it will be true. Okay, then the geometric sequence converges to 0. But when it is greater than 1, right, we can also show that it is true for less than -1. It diverges. So we can kind of write a result here. So we can say that the geometric series sequence, so I'm going to write it as A times the common ratio R to the n minus 1. That's the pattern that we saw in both cases. Right here also we saw that it's the nth term is of the type 1 times common ratio n minus 1. Here also we saw it is of the type 1 time common ratio n minus 1. So the starting term A, this is the starting term, and the common ratio and n minus 1 power, okay, that actually converges to 0 if R is between 1 and -1, like 1 half or -1 half or something. But diverges if r is greater than 1 or r is less than -1. So we have another way of writing this. When the absolute value of r is less than 1, it converges. When the absolute value of r is greater than 1, it diverges. Okay, so that's it for this video, right? We will come back with different another videos for this part, right? Okay.